In this video, we will introduce basic file I/O example within the Java programming language. Although it's preferable to access the file system via Java's new I/O APIs, in some circumstances, we will look at Java's classic I/O APIs because you'll encounter them while you modify legacy code that uses classic I/O. Applications often interact with the file system, which is usually expressed as a hierarchy of files and directories starting from a root directory. Let's take a look at our code so we can better understand how Java works with the file I/O. Java offers access to the platform's available file systems via its concrete Java File I/O class. File declares the file array listRoots class method to return the root directories of available file systems as an array of file objects. The java.io.file class attempts to provide a platform-independent abstraction for common file operations and meta information. Here we have an array of type file. We obtain this array through the method listRoots. The method returns an array of file objects indicating the available file system roots. Using the enhanced for loop, we print the available file system roots. The file class also offers a rich set of static methods for reading, writing, and manipulating files and directories. Above, we used it to obtain directory information. Now we will use the same file class to read and write files and also to obtain information on the file. Using a Unix or Linux platform, we start the path name with root directory symbol / and continue with directory name X, separator character / again, and file or directory name. Now when using Windows, start the path name with a drive specifier such as C:, and continue with root directory symbol /, directory name temp, separator character again a /, and file name xdata, although the x.dat might refer to a directory. Now that we have our file class ready, we'll write some data to it. Now let's walk through and implement some code that we can write to a file, display some file properties, and finally read the file. To create a new file with Java, you can open a file output stream to the file or invoke the create new file method, which method automatically creates a new file named by this abstract path name. This method returns true if the name file does not exist and was successfully created. The method returns false if the file exists. Now we're going to use a file writer. The file writer class is a subclass of the output stream writer that writes text files using the platform's default character encoding and buffer size. We pass our file reference to be written to the I/O, like so. Now we're going to create a buffered writer. And we're going to pass in the file writer. Now when we pass in our file writer to our buffered writer, which provides internal character buffers, text that's written to a buffered writer is stored in the internal buffer and only written to the underlying writer when the buffer fills up or is flushed. Now I'm going to write something to the file. This method sends its output immediately to the underlying character or byte stream. Now we close the stream, flushing it first. Now I'll send a message to the console notifying us that it was created successfully. We're going to catch the entire code block to write our file in a try-catch statement to handle an error that can occur when trying to write to our file. We specifically handle the I/O exception, which has the error input-output information. So here we go and make our catch statement. And we'll just simply print out the stack trace if something happens. Okay, no errors. When you need information concerning the file you are working with, Java's I/O API provides convenient methods. So here we already write into our file. So now we're going to get information concerning our file here. As we can see, this will automatically print out our file name with its path using its toString method implicitly. Can execute the file denoted by this abstract path name. This is if we can read the file. Do we have permission to write to the file? Does the file even exist? Is it a directory? Is it a file? Does it have the attribute hidden? When was it last modified? And then the file length. When we read our file, we will use something different. Here we're going to be using the file reader class, which is a subclass of the input stream reader that reads text files using the platform's default character encoding. We're also going to pass this in to the file reader, our file. We're also going to use the Java I/O buffered reader class, which is chained to the reader class to buffer input. This allows more efficient reading of characters and lines. Here we have our placeholder for our file content. The while loop will use the readLine method, which will input one line at a time to our file. System.out.println will be using to print the contents one line at a time. If there is an error, we handle the exception. We catch any kind of exception and throw a runtime exception to halt code execution. Our finally statement will execute regardless of success or failure and will close the file reader. Our close method closes the stream and releases any system resources associated with it. Now let's run our program and see the results. I right-click on my source, Run As, Java Application. Here's a list of the directories that I have. I can see here that I successfully created the file. And then I was able to read the attributes or properties of the file and also get back the contents that I wrote to it. This gives us a basic understanding and example of basic file manipulation. This concludes our discussion of basic file I/O example in Java.